Hey students, in this video we are going to find the volume of solids by shell method. Area is given between this function and the x-axis, and this area is being rotated about the y-axis. So let's start by sketching it. The shape of this function is going to be like this, but we are not given any interval or bounds of integration. So we need to find the points of intersection of this curve with the x-axis. And to find the points of intersection of any function with the x-axis, we set the given function equals to 0 and solve for x. So we solve it by factoring using algebra techniques. Set each factor equals to 0 and we get two values, x equals 0 and x equals 1. That means this area goes from 0 to 1. This is the area, and this area is being revolved about the y-axis. Let's try to use the disk method and see what happens. In disk method, cross section is perpendicular to the axis of rotation. This is the cross section, and the width of this cross section is dy. That means the integral function should be in terms of y. But is it possible to convert this given function in terms of y? It's not an easy task. So it's better to use the shell method. So let's go for shell method. In disk method, cross sections are perpendicular to the axis of rotation, but in disk method, the cross sections are parallel to the axis of rotation. The width of this disk is dx. That means we can keep the function in terms of x. When this area is being revolved about the y-axis, we get the shape like this. Draw the cross sections, and when we connect them, we get the shape like a cylindrical shell. That's why this method is called shell method. If we draw it separately, you'll get a clear idea about this. Say this is like a cylindrical shell, and we know that the area of this is going to be the radius, and this is going to be the height of this shell. So we are going to use the surface area of this open cylinder, which is 2 pi RH. 2 pi times radius times height. So let us see what should be the radius here. Radius is the distance from axis of rotation to the cross section. Radius is the distance of cross section from axis of rotation. This distance keep on changing as the cross sections move away from here to here. This distance keep on changing. So this is a variable x, and the height of this shell, this is the height. This height also keep on changing according to the given function. So the height is given by the function negative 3x to the 4 plus 3x. And now we just plug in the values into the integral function. Bounds we have from 0 to 1, 2 pi times radius times height dx. 2 pi times radius is x, height is negative 3x to the 4 plus 3x dx. simplify it little further. Let's move out the constant 2 pi. Simplify the function. And now it's easy to integrate. Negative 3x to the 6 over 6 plus 3x cube over cube. Bound from 0 to 1. Negative half x to the 6 plus x cube. And at last we plug in bounds here. Upper bound minus lower bound. So it's negative half 1 to the 6 plus 1 cubed minus 0 times 6 is 0. 0 cube is 0, so everything is 0. Minus 0. It's negative half plus 1. Negative half plus 1 gives you half, 1 half. And that gives you pi. So its volume is, we got the volume as pi cubic units. So I hope you understood how and when we use the shell method. Shell method comes to our rescue when no other way works. So see you in the next video. Take care. Bye bye.